Now let's talk about trig functions and chain rule. Pretty much any time you have a trig function, the argument isn't usually simply an x, it's usually a function. So the derivatives are the same, but you just have to remember to take the derivative of the argument here. And we usually call that u prime. So the derivative of sine of u is cosine of u prime. The derivative of tangent with respect to x of tangent of u is secant squared u times u prime, etc. So let's look at this right here. I'm going to be very painful here. If I were to take y prime, it's a derivative of sine, which is cosine, 2x, times the derivative with respect to x of the argument. So this is cosine 2x times 2, and in general we put that in the front. Now, let's talk a little bit. We're going to do something about parentheses here in a minute. This is, and your book does this, it makes this assumption that if you have cosine times 2x, this is the same thing as having the parentheses. Now what about this? If I take y prime, let's see, of this function, the derivative of cosine is minus the sine of u times the derivative with respect to x of x minus 1. So this is minus sine of x minus 1. Now this derivative is just 1, so we're done. The derivative of tangent of x, well, y prime is equal to, the derivative of tangent is secant squared u times, now I'm going to be careful with my parentheses here, the derivative with respect to x of 3x. So this is secant squared 3x times 3, and in general we move that 3 to the front. Now, as I mentioned before, parentheses will get you in trouble with trig functions. For this function right here, your book assumes that this is the argument. So this, if I were to take this derivative of cosine is minus the sine, and I leave my argument here, times the derivative with respect to x of 3x squared. So this is minus sine of 3x squared times, now what is this derivative? This is 6x. Now when we write these, you always pull this mess to the front and leave your trig function at the back. You make fewer parentheses mistakes. But what about if the parentheses were like this? This tells me cosine of 3 is multiplied by x squared. So y prime in this case, well, this is just a constant. So this is cosine of 3 times the derivative of x squared, which is 2x. You're done. Now what if we have parentheses that look like this? Cosine, and then you see the parentheses. So this means this whole thing is the argument. So the argument itself is squared. So y prime, derivative of cosine is minus the sine, and the argument never changes on a trig function, ever. So you have the derivative with respect to x of 3x squared. So this is minus sine 3x squared times the derivative of 3x quantity squared is, now we can do this one a couple ways. Do any of you have a problem if I write this as the derivative with respect to x of 9x squared? I'm going to go in and distribute that, or I could use the chain rule again. So this is, I'm going to factor this 9 out, minus 9 sine 3x squared times the derivative with respect to x of x squared, and so that's 2x. So this is negative 18 sine of 3x squared. Now here, I left myself, you cannot leave off the parentheses. For this one, this means cosine itself is squared. So to find the derivative here, we can use the generalized power rule. So I bring the power down. So this is cosine of x to the first power times the derivative with respect to x of cosine of x. So this is 2 cosine of x. The derivative of cosine is minus sine of x. So I want to rewrite this, plot my negative sign. And I always write sine x first and then cosine x. I don't know why, but I do. Now, this is very obvious that the cosine function is square rooted here. So this is cosine x to the 1/2 power. So y prime, we're just going to use the generalized power rule, is 1/2 cosine x. We reduce the power by 1. And now I need to take the derivative with respect to x of cosine of x. So this is 1/2, and I'm going to go on and move the cosine of x to the 1/2 to the denominator. Now the derivative of cosine is minus the sine of x. Now, I don't like the way I have this written, so this is minus sine of x divided by 2 square root cosine x. Now, this one is really cool. We're going to have to use the power rule a couple times. Let's rewrite this as sine of 4t, and this whole thing cubed. So f prime of t is equal to, let's use the generalized power rule. It's 3 times sine of 4t squared. Now I'm going to do this one in green, times the derivative with respect to x of what's inside. And what's in, oh, excuse me, t, not x. Sorry about that. The derivative with respect to t of sine of 4t. All right. So this first part just keeps coming down. 3 times sine of 4t, quantity squared. Now, what's the derivative of sine? The derivative of sine is cosine, and I'm being careful with my brackets here, times the derivative of what's inside. Derivative with respect to t of 4t. So you see, we're having to peel this like an onion, and we just keep writing the terms until we get to the very, very center. So we rewrite this. This is 3 times sine of 4t squared cosine of 4t, and the derivative with respect to t of 4t is 4. So this just becomes 12 cosine 4t, I just prefer writing this way, sine of 4t squared. Now, if you want a tangent line with trig functions, oops, sorry. Now, suppose we want to find a tangent line with trig functions. If we're going to find an equation of a line tangent to this graph at this point, well, you know, first of all, that you need to take the derivative. So you find f prime. F prime is 2 cosine x minus, derivative of cosine is minus sine. Now I need to multiply by what's the derivative of the inside, and that's 2. So let me rewrite this. This is 2 cosine x minus 2 sine of 2x. Now, we want to find the equation of line tangent at the point, let's switch colors here, at pi 1 prime of pi is 2 cosine of pi minus 2 sine of 2 pi. And that term is 0, and that's negative 1, so this is negative 2. So we know we have a slope of negative 2. So the equation of the line is y minus 1 is equal to negative 2 x minus pi. Now let me rewrite this. This becomes y equals negative 2x plus 2 pi minus 1. Is it minus 1? No, it's plus 1. Now I want to know, determine all the values where the graph has a horizontal tangent. Now it has a horizontal tangent whenever f prime is 0. So let me find my pen here. F prime is 0 when 2 cosine x minus 2 sine of 2x is 0. So pretty much whenever cosine of x is equal to sine of 2x. And you can do this with a number of trig. I'm out of room. It turns out these values are when x is pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. And we want to stop there because we're only looking at the interval from 0 to 2.